Hello PreCalc. This video will be viewed after Wednesday's class, so that'll be on the 4th. And we are talking about vectors a little more. And we have talked about this kind of animal where it had a pointy parenthesis. And we learned that that's a notation to describe a vector. So just reviewing real quick, this means if we're looking at a vector in standard form, where the tail or the beginning initial point is at the origin, we can find the terminal point by going -3 in the x direction. This is the x component, and 4 is the y direction. That's the y component. So go 3 over, that's the x component, and 4 up. That's the y component. So the vector, these are the components. The actual vector is from the origin to the head of the y component there. So this, we'll call it in bolded V. So this vector is called V, and it looks like that. And we talked about V having an x component of V1 and a y component of V2. Just so happens that we know them. In this case, we know V1 is -3 and we know V2 is 4. Alright, so today I want to go off of that and let's talk about what this would look like. What does this vector look like? Alright, can you give me a sketchy poo of 0, 1? Alright, I'll give you a second to get your act together. Give yourself a coordinate plane and draw in the vector just like I did up here with -3, 4. Draw the vector 0, 1. Well, after consideration and intelligent thought, you recognize that 0, 1 has no x direction. So if I'm starting at the origin, I do not move right and left at all, and it goes up 1. Say that's 1. So the vector looks like that. Alright, pretty snazzy. And that vector is so important that we gave it its own name. And the name of the vector is J. Alright, so welcome to J. And in like manner, what does 1, 0 look like? See if you can sketch that. Give yourself a coordinate plane, and this time, starting at the origin, this tells us it goes over 1 in the x direction, and it does not move up or down in the y direction. So that is the vector 1, 0. And we give it a name. Guess what it is? It is I. Alright, so I and J are very important vectors, and we will look at how we use them. They are called unit vectors because they are 1 in length. Alright, let's look at how we are going to use them and how they are important. So, remember any vector. So going back up to this one, even though it was easiest to draw it by starting at the origin, vectors can move all around. So this same vector, -3, 4, could appear over here, where it starts there and ends there if it has the same direction and the same length, magnitude. So it still means that we go over a -3 and an up 4. So these hold true no matter where I draw that vector. I can draw it down here, over a -3 and up 4. Alright, so likewise, these vectors, these unit vectors I and J, are not tied to this spot. They can go all over the place as long as they hold their length and their angle true. So J's can go all over the place and I's can go all over the place. Vectors are sneaky like that. Slippery they are. Alright, so with that I and j in mind, I'm going to teach you a new way to write vector u. I'm sorry, we called it v up here, I'm sorry. So up here, I'm going to grab vector v again. And vector v, which was minus 3, 4, in the pointy parentheses. We're sick of pointy parentheses. So we are going to draw minus 3, 4. We're going to have a new way of saying the same thing. So again, the vector is the same right here. But to get the x component, and think of it this way, instead of going over minus 3, we're going to say that we're going to go over minus I, because if this is I, this would be minus I. So I'm going to go minus I once, minus I twice, and minus I the 3 times. So I'm going to recognize that this component can be written as minus 3 i's. 1, 2, 3. And then, looking at the j vector, I can go up 4 of those. 1, 2, 3, 4. 4j. So, the way we communicate that, we say negative 3i, we write the I part first, plus 4j. And that is the same as saying minus 3, 4. So you have 2 ways to say the same thing. With the unit vectors I and j, or with the pointy parentheses. Notice these require no parentheses at all. I tend to like I and j notation better, and here's one reason. I know you're dying to know why. Suppose the u vector is minus 3i plus 4j, same old one, and let's come up with another vector. So v is 2i minus 1j, so minus j. When I write these out, I am going to ask you to find 2 times vector u minus 3 times vector v. So this is my v vector. So algebraically, this can be accomplished with this form as well, but I'm going to show you how you do it with this form. So we want 2 of these. So I'm going to put a 2 in front of the minus 3i plus 4j, and we want a negative 3 vector v, and vector v is 2i minus j. So I replace the u with the I and j form of vector u, and I replace v with the I and j form of vector v. So now it works just like algebra. The 2's distribute, and we confirmed that yesterday, that the constant can be distributed among the components. It's one of the properties. And over here we distribute the minus 3. And then we can add i's to i's and get a negative 12i. And j's to j's, and we get 11j. Alright, so if you were to add this vector and this vector, you would get this as the answer. Oh, not this vector, but twice this vector minus 3 this vector, you would get this answer. Alright, so that'll set you up for success on some problems tomorrow. Before we leave our lecture for tonight, let us look at this vector, vector u, and it equals 3i plus 3j. So, I want you to find the magnitude and direction of this vector. So 3i plus 3j. Alright, so sketching it, we go out 3 unit vectors I, so brings us out to 3. And I'll put the 3, there's 3 of them. Put the 3 over here. And then we go up 3 in the j direction. 1, 2, 3. So there's 3 in the j direction. So the question asks for the magnitude, which is the length of the vector. So here's vector u, and we're looking for its magnitude. We indicate that, we learned yesterday, with the double bars, meaning the magnitude or length of vector u. You can see 3 and 3 are sides of a right triangle, so to get the hypotenuse, which is the magnitude, we just do Pythag. 3 squared plus 3 squared is square root of 9 plus square root of 9, which is square root of 3. The square root of 3 squared plus 3 squared is the square root of 18. That reduces because we know that 18 can be written as square root of 9 times square root of 2, and the square root of 9 is even 3. So we go back up here and we say the magnitude of vector u is 3 square roots of 2. Do not give me a decimal. They are demonic. I want the actual value. No approximations. So that took care of magnitude. And now let's do direction, which is simply finding the angle. And we see that if we use these two sides, opposite the angle and adjacent, that's the tangent function. So the tangent of the angle is opposite 3 over adjacent 3. And tangent will help us always get the direction. So that's really a 1. And our calculator knows what angle has a tangent of 1, and perhaps you do as well. That takes place where does the second coordinate divided by the first on the unit circle equal 1? It happens at pi over 4 or 45 degrees. So that is the direction that was asked for. So we got the direction. Magnitude, we're going to use Pythagorean theorem and tangent to find the direction. All right, what if this wasn't on the unit circle? Then you would have to go into your calculator, and it knows what angle has a tangent of 1 by using the inverse tangent button. Inverse tangent of 1 will give you that angle. So if you do that and you're set on degrees, you'll get 45 degrees as was expected. If you're set on radians, it's going to give you whatever 3.14 divided by 4 is. So it's not going to give you the nice pi over 4, which I want. But if it's not on the unit circle, I'll have to accept the decimals. All right. We'll try to do these. I think in math, in this part of the math, we can use degrees and get away with it. Okay, let me remind you though that the inverse tangent on your calculator is also a slippery animal because it gives you some wacky answers, and we have an inverse tangent map that helps us take those wacky inverse tan answers and convert them to something we're used to. So if your vector's in the first quadrant, just take what the inverse tangent gives you. So like this one was in the first quadrant. So inverse tangent of 1 is going to give me a 45, which I don't have to adjust. If it's in quadrant 2, I want you to take what the calculator gives you and add 180 to it. And if it's in the third quadrant, take what the calculator gives you for your inverse tan and add 180. And in the fourth quadrant, add 360. And you'll get the function that we like. The calculator is always going to give you the value from the x-axis to the vector, and that's not normally how we represent angles. So let's do another one. Say that the vector is 3i minus 4j. And when we look at that, sketch it. So we go out 3 unit vectors and down 4 j unit vectors. So this is a 3 and this is a minus 4, so our vector ends up down here. And we want to know the magnitude and the direction. So the magnitude is Pythagorean, 3 squared plus minus 4 squared. 9 and 16 are 25. The square root of 25 is 5. So that's the magnitude. We indicate it with the double lines, and that equals 5. The inverse tan, however, is going to be, remember, tangent of an angle is opposite over adjacent. So we're going to take the inverse tan of negative 4 over 3. It's always going to be the j part, this is the j part, divided by the I part. So you'll recall in physics we called it the y component, which it is still, and divided by the x component. So let's practice our mapping by plugging that into our calculator, since tan inverse of minus 4 over 3 is not on the unit circle. So in degrees it should come out to negative 53.13, but I prefer a positive answer. It's in the 4th quadrant, so I'm going to add 360 to that number that the calculator gives me, and it gives me 306.87 degrees. So that is the angle that we have in that problem. So 306.87 degrees. All right, let's go the other way, and then we'll call it a night. The other way goes like this. I'll give it a little bit more meaning. Let's say that a plane descends. This is a planned descent. The plane descends at 30 degrees at 2 o'clock in the morning, and it is going below the horizon at 30 degrees, and I'll show a picture of it, and it's going to be traveling at 100 miles per hour. I want you to find the components. Find the components of that vector. And when I say components, I'm looking for i's and j's. Alright, so sketchy. Let's do a sketchy. We have a horizon. The plane is descending at 30 below the horizon. So I'll put a 30 degrees there. And I'll think of it as being on the coordinate plane. And the plane is going at 100. So that's the vector magnitude right there. So I am asked to find the components. So I want the I part and the j part. To do that, you'll recall we've met this in physics, and we've also met this in math. To get this, because the sine of 30 is opposite over hypotenuse, we know that j is going to be 100 sine. Remember, the vertical is always sine of, I'll say 30. But you see when I put it in parentheses, I'm going to come back and adjust that. And the I part is 100 times cosine 30. But it's not really a 30 on the coordinate plane the way I situated it. It's really what? So instead of 30, I have to recognize on the coordinate plane, when it's going in that direction, it is not 30. It is 180 plus 30, which is 210. So once you draw your coordinate plane, adjust the angle from the problem. So that's on the unit circle, sine of 210. So this 100 times the sine of 210 is 100 times, what is that, minus square root of 3 over 2. And cosine of 210 is 1/2. So this part becomes 100 times negative, sorry, negative 1/2, both negative in that quadrant. So this comes out to be 2 goes into 150, so we have minus 50 square root of 3 over 2, and over here we have minus 50. So let's put that in a form that makes everyone happy. So the I part right here is negative 50I, and the J part is minus 50 square root of 3 over 2J. And if you're using pointy parentheses, you are going to put the I part as minus 50 and comma, and then the J part minus 50 square root of 3 over 2. Alright, I think that will get us where we need to go for our classwork tomorrow. So this time we started with a vector's magnitude and direction, and we went to the components. Previously we were given the components and went to the magnitude and direction. Alright, we've seen this in physics, and hopefully it still is fresh in your mind. Alright, so I'm just thinking about something. Cosine of 210, I'm just checking. Cosine of 210, I think I got that mixed up. Let me draw my unit circle. Trying to do it in my head might have messed this up. So 210 is right here. So we go back square root of 3 over 2 and down 1/2. So when I did the cosine of 210, I think I grabbed the wrong, I grabbed the wrong coordinate. It's the first one. So this should have been, instead of negative 1/2, this one should have been negative square root of 3 over 2. So let me trace that. I went back up here and changed that negative 1/2 to negative square root of 3 over 2. So the sign is negative 1/2. I had those switched. So let's go back and adjust those. So this is negative 50 in the J direction, and up here in the I direction it's negative 50 square root of 3. So I just have these backwards. Hate when that happens, but I'm glad I caught it before I turned off the video and left you in despair. Alright, so negative 50 square root of 3I and negative 50J. Alright, I hope that wasn't too upsetting. I'll change this as well. The I part is negative 50 square root of 3. Oh, we don't write the I in there. And in the pointy parentheses form, we don't use the I in the J. So I'm glad I looked at that as well. Alright, I better stop now. Alright, very good. Have a good rest of your evening, and I will see you in class where we will have an opportunity to work these out for ourselves. Alright, till then, goodbye.